the solution is given here, that we have to abandon particles and use numbers if we want to get a correct description of space and time inside the black hole. Now, the question is, how this suggestion made by the singular numerical relativity regarding quantum mechanics reconciles with what we have learned already in general relativity, that there it says we have to study Galileo's experiment. Galileo measured the speed of objects in a free fall because he realized that when an object is in a free fall, it doesn't follow a constant speed. The speed is not uniform. Instead, the speed changes as it goes on. So here, Galileo measured exactly the speed of objects in a free fall. And he found that the distance an object travels is directly proportional to the square of time. Distance equal time squared. So here we have only numbers. We have the time is 1, distance will be 1 squared, 2, 2 squared, 3, 3 squared, 4, 4 squared, 5, 5 squared, and it goes on. So how to know what goes on here? And I would like to mention to you that this is exactly a description of gravity. Through Newton, we know already that objects fall because of a force called gravity. So it's gravity that works here. By studying how numbers change, we can understand exactly how space and time interact. So only numbers are our guide here. To explain this, the singular numerical relativity will use ideas from special relativity given by Einstein. Einstein said, for example, time and space are one. We are going to use the ideas of Einstein in special relativity regarding space and time to describe what goes on here when an object is in a free fall. And that's a description of gravity. It means that Einstein had an opportunity to explain Galileo's experiment. Galileo prepared this experiment for Einstein to use and explain gravity for all the realms of the universe. Now you know. Yes. The singular numerical relativity is going to do that. The singular numerical relativity will explain gravity for all the realms of the universe at once. That's why it is going to build one-way bridge between quantum mechanics and general relativity. We say one-way bridge because at once it will explain everything, and we don't need the formulas of general relativity or quantum mechanics to explain this. This theory is axiomatic. By itself, it will do the job. So this is very provocative for scientists, for all physicists, of course. But it is a reality. Why? Because numbers are the true building blocks of space-time. The true building blocks of the universe at the fundamental level are numbers. Numbers are flexible as space and time are flexible. So we will have this complete explanation of the geometry of space-time based on numbers. When we will have done that, then everything will be okay. Everything will be all right. As you can see, this theory doesn't need to be named quantum gravity theory. Because if it can explain gravity for all the realms, it doesn't mean it's quantum. The word quantum, yes, but one thing is true. Quantum gravity will transpire in the description of space-time in 2 dimensions. Quantum gravity will transpire there. But the theory itself is going to explain so many things. That's why it doesn't need to be called exactly quantum gravity theory as expected.